Okay, math fans, our topic for today, this is notes 13-4, compound interest. And you'll see that I scratched out. This is a set of notes I taught at another school and the course was Advanced Functions and Modeling, but this is for our Integrated Math 3 class. Our goals for the day after this lesson, students should be able to, number one, determine the future value of a lump sum of money. Number two, calculate effective rates of return. Number three, determine the present value of a lump sum of money. And number four, determine the time required to double or triple a lump sum of money. So there's a lot of things we're going to be talking about here. Before we start, let me give you your joke of the day. Why did Mr. Cavell not want to tell horror stories to his math class? And the answer is he thought they would be too squared. Too scared. All right, so we're going to start here. The first part of this is talking about what's called simple interest. The idea of interest, if I wanted to buy a house, the problem is that I would not be able to pay all the money at once. If I have to pay $100,000 or $200,000, well, most of us are not going to have that amount of money in cash. So what we have to do is we have to go to a bank or some other institution and get a loan. Now, the bank or the other institution, they might loan us the money. So if I had to pay $200,000, they would loan me the money, but I would have to pay them back. Plus, I would have to give them some extra money. And that money is called interest, the extra amount that I have to pay. So interest can be a bad thing if you owe that much, because whatever you pay for a certain commodity, you end up paying more than what the price is that's listed because you have to pay interest. But interest can also be good if you are loaning to somebody else, or if it's something with investing where you are earning interest on the amount that you are investing. Simple interest is the idea that one time each year, maybe at the end of the year, you get paid a certain percentage. And so here's the formula. It's I equals P times R times T. So you see a lot of variables here. I is the interest. So that's the amount of extra money that we would make or that we would owe. P is what we call the principal. That is the starting amount. So it's the amount that you borrow or that you are investing or loaning to somebody. R is the rate. Now, it's usually given to you as a percentage, but when we type this, when we use this to calculate, we always write it as a decimal. And then T is the time in years that we are investing or that we are borrowing. Okay, so for example, let's say that our principal, let's say we invest. I like to talk more about investing because you're actually making money instead of owing money. Let's say we invest $4,000. Let's say that the rate is 5%. And let's say we do this for 6 years. The question is, how much money will we have at the end of this period? Well, what would be the interest that we would earn? Well, interest is the principal times the rate. Now 5% is 0.05, and then the time is 6. And what you're going to see is we're going to do a lot of calculator work in terms of our computation here. All right, so if we take 4,000, and I can just use parentheses for my multiplication, times 0.05, and then times 6. Enter. And what we get is 1,200. Okay, so our interest would be $1,200. Now that's the extra money that we would be making on that. Not too bad. Let's say the time was only for 1 year. Okay, so let's say same thing, but the time is only 1 year. How much would we make in 1 year? So principal is 4,000 times 0.05. Now the t is 1, so times 1. And if we work that out, that would be $200. So if, this is I equals, not P equals. So our interest would be $200. So let's say this is our investment. Every year, we are getting paid $200. That is free money that we are making, and that you can then choose to spend, invest, things like that. So interest can be a good thing if you're making it. If we owe this money, then it means that we are paying $200 every year. And if we did this for 6 years, we would be spending an extra $1,200. All right, now, there are different payment periods, though. It's not always going to be simple interest. Payment periods can be annually, so that's just once a year. Semi-annually would be twice in a year. Quarterly, if a stock pays you a dividend, which is an interest payment, basically, quarterly is 4 times. There are 4 quarters in a year. Monthly, if you have a bank account that pays you interest, like maybe a savings account, monthly is 12 times a year. Weekly, well, there's 52 weeks in a year. Daily is 365 for that. So simple interest, here's the formula. Now that's, again, you're getting paid one time each year. But that's not the best way to make money. The best way to make money is what we call using compounded interest. If I were to take my interest, so let's say I was making $200 each year in interest. What I would really want to do is take this 200 and in the second year, add it to my 4,000. And so what would happen is that the second year, instead of having 4,000 again, the same starting amount, this would increase. This would be 4,200. So if that was the case, compounded is where you start earning interest on that extra money, on your interest. And so what happens is that your amount of money is going to grow as you compound. So compounded is when the interest is added to the old principal and then becomes the new principal. And what you're going to see is that compounded interest, if you are an investor, this is what really will make you money, is that you let your interest, your extra money, you add that on to your principal. So the amount you start with keeps getting higher, and the higher that goes, the higher the new interest is going to be. So compounded, we're going to use a variable n. N is the number of times compounded in 1 year. Basically, I think of compounding is how often are we going to recalculate our interest and our amount. Okay, so as an example, let's say we have $1,000 deposited in an account at 4%. So the rate is 4%. The amount we deposit is the amount that we invest or that we put into the account. That's our principal. That's what we start with. How much interest is earned in 1 year? That's our time. If interest is compounded annually. Now, annually means one time that this happens. So if I wanted to calculate this, my interest would be my principal, which is 1,000, times the rate. Now this time 4%, that would be 0.04. My time is just going to be 1. And if we calculate that, we would earn $40 in interest. Now what that means is that the new amount, so I'm going to put another variable here. I'm going to use capital A. That is the amount. $40 is the extra money, but remember that we're starting with 1,000. So the new amount would be 1,000 plus 40, which is $1,040. So if I was doing compound interest for the second year, my starting principal would not be 1,000, it would be 1,040. Now let's say that we do this, but this time we will do this semi-annually, which means we're going to do this 2 times during the year. If we go semi-annually, then maybe you would get one payment in June or July, halfway through the year, and then you would get your second payment, your second calculation would be in December, at the end of the year. Now, what's going to happen here, because we are doing this twice, the principal, we start with 1,000, the rate is the annual rate is 0.04, but if we're going to calculate the interest twice, that doesn't mean they pay you 0.04 twice. That would be awesome if they did. What they do is they take the number of times. This case, we're going to do it twice. So 0.04, we're going to divide that by the number of times we compound. So they're going to give us 2%, let's say in July, and then they'll give us the other 2% in December. Okay? Now, if we calculate this here, we're going to get $20. And you're going to say, oh, wait a minute. I'd rather do this annually because I get because I get 40 extra dollars. But the problem, or the nice thing is, this is only halfway through the year. So we're going to take this 20 and we're going to add it to 1,000. So the amount after 6 months is going to be $1,020. Okay, so now this is July, right? We're only halfway through the year. So then we go another 6 months, and then we're going to calculate interest again. The difference is that our new principal is no longer 1,000, it's 1,020. Now remember, the interest rate was 4%, but we divided that into 2 pay periods, so that's 0.02. Now if we multiply that, we are not going to get $20. We're going to get $20.40. Okay, so if I do this with the calculator just to show you, 1,020 times 0.02, 20.4, which is $20.40. Now the new amount would be the principal, 1,020, plus the extra money. And so the amount would be $1,040.40. Okay, now look at what happens here. If we only compound interest 1 time a year, if we do it annually, this is the amount we end up with. But if we do it semi-annually, if we calculate it twice, we actually end up with some extra money. We get a little bit more. So what would happen if we increase the number of times we compound? So let's say we do it quarterly now. And I'm going to go through this. Okay, and this is going to take a little while. I'm going to show you where this is coming from. There's this nice complicated formula beneath here. So if you want to, to understand how am I deriving my formula, keep following with this. Okay, if not, if you want to just skip along to the next part, you can. So if I do this quarterly, that means 4 times a year they're going to calculate interest. Well, if I take 4%, and I divide that into 4 pay periods, that means each pay period is 1%, which is 0.01. Okay, so the first time we do it, we take 1,000 times 0.01. Now I'm going to go through the calculations a little bit faster here, and that's going to be $10. So the new amount is the principal plus 10, and that's 1,010. Second pay period, we're going to take 1,010, multiply by 0.01. Now we're going to get a little extra interest here. We're going to get $10.10, so the new amount is 1,020.10. We're going to do it again, third pay period. We take 1,020.10, multiply that by 1%. What we get is we get $10.20. So you see there's a little bit of a pattern in the increase here. The new amount, we add that to the 1,020.10 and we get 1,030.30. Now we do want to be careful here. You might be saying, oh, it goes up 10 cents each time. Not exactly, because if we do this one more time, so 1,030.30, multiply that by 1%. The interest is 1030. And so the total here is going to be 1,040.60. If I kept going, eventually my increase would actually be more than 10 cents. It might actually get up to 11 cents. All right, here's the final amount, $1,000.40 $1,000.40 and 60 cents, $1,040.60. Okay. So we've got each time you compound, as you increase that, you are increasing the amount that you're earning. Now you might say, well, that's not much. That's 60 cents more than just compounding annually. Yes, but imagine you're investing more money. Imagine that you are compounding more times. Over a period of years, compound growth is going to be much more significant than just a simple interest rate. So here's where I'm going to come up with the formula. So let me show you this with the variables. I am taking my amount is I take the original principal and I add on the interest. Now the interest is the principal times the rate divided by n, the number of times I'm compounding. Now let's think about factoring here. Both of these have the letter p, so we can factor out a p, which leaves us 1 plus r over n in parentheses. Now that's after the first period. So then we come to the second pay period, the second quarter, and the amount is we take the principal. Now the new principal is p times 1 plus r over n, and then we add that to the interest on that, which is we take that new principal times the percentage, which is the rate divided by the number of times being compounded. That's this r over n in this case is 0.04 divided by 4. That is r over n. Now, this is getting a little sloppy, but notice that both of these terms have the same p times 1 plus r over n. So if I factor that out, what that's going to leave us in the first term, I factor out the whole thing, that just leaves us 1. And in the second term here, it's going to leave us with the r over n. And so notice that I have the same parentheses multiplying each other. So that is p times 1 plus r over n squared. That is the new amount. Now, if I do this for the third time, we could keep going through this process, but what you will see is that the only thing that's going to change out of this is the exponent will become to the third power, and then finally, in the fourth quarter, this will go to the fourth power. Just to show you that these are actually the same, if I take, so A is the amount. Now P was the original principal, which was 1,000, times 1 plus R, the rate is 0.04, but remember, I'm dividing that into 4 pay periods, and then if I raise that to the fourth power, we get 1,040.6, and that is the end of part 1.